Every few months, the McMaster website goes viral for being super fast, and it really is. Just navigating the website feels like it's flying, and the fact that it's using things that aren't modern web tech is really interesting. But is it just vanilla HTML, and can we go faster if we branch away from that? We have a lot to dive into here. This isn't a simple thing to cover because there's so many misconceptions about what makes websites fast, what makes McMaster fast, and what makes websites slow. And quick spoiler, yes, the McMaster site is fast, but we'll also be covering a rewrite of it in Next that is comically, absurdly faster. I can't wait to show all of this to you guys. There's a lot to learn here. But before we do, a quick word from today's sponsor. Today's sponsor is me, because I couldn't get a sponsor in time for this video. Turns out doing 2+ videos a day is hard to fill with sponsor slots. So if you're a company, a brand, or know a company or brand that might be a good fit for the channel, hit me up at youtube@t3.gg. First, we need to start here. I do have a fast internet connection, which is of note, but the site still flies, and I think it's fair to just leave it on. I could go turn on throttling, but I don't care. I want to show you guys how fast navigating it is. I'm going to hover over nuts and click as soon as I hover over nuts. You see a little loading spinner, but you get to the page relatively quick. And when I click cap nuts, it loads immediately. When I click corrosion resistant, it loads pretty much immediately. And now down here, I can click a specific product ID and add it to my order. Things load very quick. And when I navigate backwards and forwards, we get a little loading spinner for a sec, but then we're on the page. It feels really good to navigate this site. There are things here and there, like the fact that the loading spinner hides the sidebar sometimes and doesn't other times. But it overall feels really good. If we open up the network tab, we can start getting an idea as to why. Notice when I hover over something for the first time, something happened here. Content web part. They have JavaScript that runs on the client that tracks when you hover over things and immediately starts to prefetch them. So when you click it, it can load immediately instead of having to go to the server on click. This is the thing that we often do with single-page app frameworks, where we try to preload things based on user intention, like hovering over the thing or it being visible as a link. So you can use different prefetch strategies with a lot of tools, but because they're not using a traditional single-page app framework, they don't have those. So they built their own, and they built them on top of their ASPX backend. Yes, this is all written with .NET. And the reason it's fast isn't because .NET is fast, which, by the way, .NET is insanely fast. The reason it's fast is the prefetching work and the client-side JavaScript that they have running. It's not fast because it's standard HTML. In fact, if we look at this response, let me just open this in my editor really quick. This is not standard HTML like I've ever seen it. We have this giant thing at the top here, this weird pile of numbers, and then a gigantic JSON object as the first thing in the response, not as a script tag in the response, just as a pile of data that might be needed on the client side. And it's a lot. There's a lot of data in that response before we even start the HTML chunk, which is here. We see the prod page content inner ID, and we see all of these elements all named in the wonderful .NET way. And we can see the actual HTML that's going to come in and replace the page if I do click on that portion. But all of this is in order to get what the server thinks the page should be if I click that, and what the client needs to do to actually get me there come together properly. But this is all being stitched together with their own JavaScript that does it all. So if I click here, click JS, you'll see there's actually quite a bit of JavaScript being loaded. Even if I open this in like an incog where I don't have any Chrome extensions or anything, you get quite a bit of JS on the first page load, over 1.5 MB of it. That's pretty nuts. And the reason for that, let me just expand this so you can actually see the URL. So you can see all of these are indeed McMaster. They do this because they had to write a bunch of JS in order to make it so when you navigate, they can swap things out, they can preload things, and do all of these hacks to make it feel like a fast experience. Apparently, 2 of these JS files don't even exist and failed to load, which is kind of funny. This one does. You know they're serious when the first line in their JS file is a performance.mark call. That's how you know they're in this for real. How they're not just playing the game, they're here to win it. But you see all these crazy things they're doing. Like, I'm sure a lot of this is just because like JS minification and obfuscation is weird. But there's a lot of code in here about offsets and render locations. It's possible this all comes from a library they're using. And if somebody in chat knows if that's the case, let me know. But as far as I can tell, they built their own JS layer to do the swapping and the slicing and the editing of the HTML on the page and the HTML updates they fetch from the server. Chat has too many good puns. I have to show them. The force does on the page was great. They're not screwing around. It's pretty nuts. You guys get your win this time. Try regenerate runtime equals runtime. Catch accidental strict mode. This is something else. I would love to see the actual code for this code base, not the minified chaos version. I'm so curious how it is actually written and how it's actually supposed to work. Got all these defined relationships. This is nuts. But yeah. So for everybody online who's been saying, obviously it's fast because they used vanilla HTML and JS and they didn't use a framework like React. That's why it's so quick. You're fucking dumb. Look at the network tab. This page loads more JS than half the things I build. And that's fine because loading JS isn't what makes a page slow. It's when the JS blocks things. It's when the JS takes a while to run, not just load. And it's when the server doesn't respond fast enough to user intent and interaction. And the solution here isn't write it in something faster. The solution here is understanding the needs and expectations of a user who's experiencing your product and to try and optimize around those things. Different tools can provide better defaults, but different tools do not magically make your website this fucking fast. You don't make a website as fast as McMaster without having a business interest and time that you're putting into it. You get here because it's your job to, or because you care too much. And with McMaster, they wanted to do better than calling them on the phone. And if they make the website so fast and so reliable that you can fat finger it with a glove on, awesome. And as Chad has correctly pointed out here, rolling your own framework is indeed still using a framework. Absolutely. If you look at the page speed insights for the page, you might actually be surprised. They're not great. The interaction to next paint time is relatively slow because it's loading a ton of JS. And their performance number here is actually surprisingly low. Hitting a 61% there is sad to see. Then their JS execution time is insane because they're, again, running so much JavaScript, but it doesn't feel slow, even though they have all this JS. And if anything, I think this showcases how the page speed insights and how Lighthouse doesn't give you a full picture, so to speak, because it still feels great to use the site. But all the things that we have been told are how you make a website fast are either not what they're doing or are not true here. But I do want to try something else quick. Let's check out NextFaster. Before I do that, I want to try it here. I want to see what the page speed insights are. Quite a bit better. And if we wait for the diagnosis of performance issues, I have a good feeling there too. Come on, Google. There we go. Still not a perfect score on performance, but accessibility is better, and it is overall good. Well, let's take a look at how it actually feels to browse it. This is NextFaster, a copyright distinct entity, as a demonstration of what a website that vaguely looks and navigates similar to McMaster, but is totally not McMaster, or even a reference to it. Yeah, there may or may not have been some weird copyright bullshit in that world. Not what we're here to talk about. We're here to talk about NextFaster because it fucking flies. I click. I'm just going as fast as I can here. Everything loads instant fucking taneously. As soon as I hover, I'm clicking. I'm just clicking as fast as I can here, and everything loads immediately. There's no pictures popping in. It doesn't feel as good as McMaster. It feels comically better. Like, none of that is sped up. I was just live doing that as I talk. It's insane. And we have to cover the hacks they did to make it that fucking fast. Huge shout out to Ethan Nicer. His YouTube's in the description too, for the work he did on this project, as well as Reese and Armin for helping with everything from orchestrating it to getting mock data and generating that all with AI. The result shows, and the fact that they made something not just slightly faster, meaningfully, obviously faster, is kind of absurd. And if I was McMaster, I'd be quaking a bit because now any of their competition can make something that eats their edge, which is that their site is the fastest by a lot. So let's start with cache disabled fully. The full page load, all of the data is about 2 megs. And since nothing is cached, it's going to keep refreshing it. But if I turn cache back on and I Command-Shift-R, I have to stop and reset all of this actually. Clear, record, reset. It's about 300 kilobytes transferred. Not bad at all. Like, at all. It's basically no data. 3.6 megabytes decompressed, but the fact that it's that little, especially if we just look at the JS tab, how funny is it that the amount of JS being loaded on the next version is significantly less than the amount being loaded on the vanilla HTML version? But where things get interesting, and chat's already catching on, is what happens when I scroll. As I scroll, it's doing these additional fetches. And you'll see that little underscore RSC thing. What's that? Can we look at the response here? No? Didn't give me one? Okay, here's some. So here we have the needlework response. If we open this up in my editor to take a look, this is all of the data that is needed to render that next thing. It includes the data that goes to each of these individual tags. It is just JSON, but this JSON is going to be used in the next route. So that one all came from, where did that one come from? We also just preloaded all the images somehow. This was needlework. So if I click needlework, all the images are preloaded already because it knew what data needs to go there. It's already in the instance in the browser, so it can stuff those in really quick and even prefetch the images if that's the right call. Watch what happens when I hover over a page. It immediately starts to preload the images for the next route when I hover over it. So I hover over the needlepoint yarn, it fetches all the images on that page before I even click. And then when I click, they're all already here. That's nuts. That's super cool. And the reason that this all navigates immediately is there's a lot of these simple to come up with, but not necessarily simple to implement optimizations that make the website move as fast as you can fucking click. I'd even bet that if I go turn on 4G slow throttling, it still is going to navigate comparably quick to the McMaster site. The images will take longer to load in because they're images, but everything else is instantaneous. I click and I'm on the page I clicked on. It's kind of nuts, but I can just sit here and show off how fast it is. We got to actually look at the code, which is why I downloaded the repo. It's also worth noting that because this is Next.js, the backend code and the frontend code aren't even different repos, much less different fucking languages. It's all here. Good point, Gabriel. Apparently the preloading I was showing before with that file I had here, this is literally just preloading for the images. So when you hover, it knows which images to preload. Huge optimization, really clever stuff. Back to the actual code though. So here we have the homepage code. It grabs the collections and the products in a promise.all so these can run parallel. We could even go look at how these queries work. In here, we have the DB select. We're using unstable cache. This could just be used cache now. That's finally shipped with a custom revalidate of 2 hours. So now we don't have to wait for this call to happen because it's cached and the new products probably aren't coming out that much. And even if they are, every 2 hours, it gets updated. Awesome. We have all these queries that are doing a bunch of joins, all using Drizzle. They preload all the data in the database using Drizzle and AI-generated fake product shit, which came out really good overall. But all the queries are just basic DB queries using Drizzle with a bunch of cache validation headers. Not even a bunch, just the revalidate function using the unstable cache like wrapper. Nothing here is stuff that you can't write. It's all relatively easy to do. It's all standard Drizzle code. I have a bunch of code in my code bases that looks very similar to this. So that's not where the magic is. Let's keep hunting. Let's find that magic. Here we have collections.map, and we write out all the collections. And then for each of them, we put all the things or all the subcategories that exist there. Here's where we can start seeing some of that magic. Here's the first line of magic. Prefetch equals true. This is telling Next.js, and in this case, the JavaScript runtime for the Next.js router on the client, hey, by the way, go load this page once this element appears so that when you click it, it can happen immediately instead of happening when the user clicks. So you don't have to wait to load the page. You click it and it's effectively preloaded. That's what prefetch means. Images have some of these hacks, but there are some fun things in here. First off, we have this loading call, which is to determine which loading behavior should exist for this image tag. And we have this in an interesting spot. If the image count is less than 15, then we render it eager. Otherwise, we render it lazy. The reason we do that is so that some images have a higher load priority than the other ones. And this image count is a variable that's defined up here. And since this is a server component, it only runs once and then dies. You can do something weird like this. So every time we render a new image in this view, the image count goes up. And if it breaks 15, then we start switching the new images to load lazy instead of eager, which means you will see those first 15 images much quicker and the other ones can load in later. Decoding sync it's effectively like sync is blocking, where it will do it ASAP because these images are simple enough that it should be able to render them really quickly and we shouldn't wait and have them pop in later. That's my rough understanding. Good call out on prefetch for link, by the way. Prefetch the page in the background. Any link that's in the viewport will be prefetched. So it's not just you hover, it's the link is visible. So if there are links that aren't viewed yet because you're not at the part of the page, they won't be prefetched. So now that I'm here, if I scroll, you'll see here as I scroll, all of the preloaded data appears because it's being fetched in case I click the link. And here you'll see the watercolor paper for printmaking is there, and it has a bunch of the data that's needed to load that. So now when I click it, the page can load immediately because it's smart enough to do this type of prefetching. And that's not something crazy that they built themselves. That's just turning on prefetch true. And even if this wasn't there, it would still be really fast. But if there was a loading state in between, like you had a loading JS file that would have hit before you loaded that data, that file will basically say to the router, hey, only preload up to here. But when you set prefetch true, as they say here when you hover, when it's null, it will load a dynamic page up till it hits a loading JS. But when you set it to true, it will load the whole thing, including whatever would have been under the loading JS, which means any data fetching and other things you need to do get done. You have the page, and when you click it, it loads immediately. Really nice. A few more things with image. They're doing the Next.js image optimization, which is really good, and there's a reason they push you to use the image component. It makes your stuff load way faster. Quality 65 is a bit aggressive, but I bet the resulting images are hilariously tiny. Actual images, like 40 kilobytes for some of these. Some are even smaller. Yeah, like 20 kilobytes for some. The image files are tiny, which is great because they're in a tiny viewport. They don't need to be huge. They could go further. If they go further, it might cost them decode. But if we go to like pick thing, which is a tool I built for managing the images I use for things like my thumbnails, and I want to right click, copy image address, open that in new tab. This is a decent looking image and optimized. Yeah, my image here is only 4.3 kilobytes. So you could optimize further, but when you optimize further, the result ends up being more CPU cost. So if your device doesn't have enough CPU to decode these really like well-compressed images, then your experience will end up being slower. And finding the right balance between compressing as good as possible and not screwing the user's CPU is tough. So that's all we have here. That's not much magic. This is all stuff any of us could have done in our next code bases without thinking too much. It's a prefetch true and a loading counter. There has to be magic somewhere in here, right? Let's keep hunting. Let's find some of the magic. We'll look at the collection page. This one's complex, right? So they're using this wonderful function in Next called generate static params. I personally never had a good use for it, but this is a clever one. What this does is at build time, it runs the code here, and whatever you return, it needs to be a list of the params that could be on this route, because this route is /collection. So whatever the ID is there, whatever the slug is there, if you write this function and export it on the route, at build, it will make an array here of all of the strings that are valid collections, and it will generate the page for all of those. So at build time, we are generating pages for everything, which allows it to be much faster because now we don't have to block on the server to get you something back immediately. And here we actually use the parameter, which in this case is collection string, again, just from the name of the file there. Let's see how we use it. We decode URI component to grab it quick so that it's formatted properly, and if somebody's doing some weird URL encoding shit, it's handled. We grab the collection by calling await get collections data, which again is just an unstable cached database call. Let image count to 0. Huh. It's the exact same thing again. Is there magic anywhere here? There has to be, right? There's no way this can just be such simple code in order to be faster than this site that was super well architected, right? You got link, prefetch true again. Image, loading is eager still, decoding is sync. There's nothing magical here. Where's the magic hiding? They had to hack Next to make it this fast, right? There's no way Next could just be fast like this. It's slow. It's all JavaScript. There's no way. Well, the more you scroll, the more you realize the language isn't the thing slowing you down, and the JS framework you choose isn't determining how fast the performance of your app is. Does it have the features you need for it to go fast, and did you take the time to pick the right things? Maybe, just maybe, there's something going on in the Next config. We'll check that. We have partial pre-rendering set to true. TypeScript and ESLint ignore build errors. These are really good flags because you can check for these things during your CI and not block your deployments on them, which is really handy. We have the images helper, which has a minimum cache TTL. I should probably turn that on things because we never want to re-optimize an image ever. And then remote pattern, which is their Vercel storage, blob storage thing. Personally, I'd recommend upload thing, but Vercel storage is decent. And once you're putting things in, if the users aren't putting things in, the place that your storage is doesn't matter. But if users can upload, you need to make sure you have that all blocked down. But here it doesn't fucking matter. It's just R2. And then some rewrites. These are to make sure that things like your vitals.js file and your heartbeats don't get blocked by an ad blocker. But where's the magic? How is this fast? Maybe we need to check the PRs. Let's check those. Pull requests, 57 closed. So a lot of people have been contributing. Actually, let's just look at the contributors quick, because I think it's pretty funny to see. It's kind of like a who's who. We obviously have Reese and Ethan high up. We have Armin here, who generated a lot of the data. And we have a bunch of other people who helped contribute, including Cramforce, who's the CTO of Vercel, including Tobias, who's also observability at Vercel, Lee Rob, you've probably heard of before, Stifle, who I adore, one of the people most involved in maintaining Next, and Eminat, Samin. I can't say I'm familiar with him. Use GitHub. Clever. So what have these people contributed? Where is the magic? Anything here that seems like it'll be really fast? Change cache from 10 minutes to 2 hours. Cool. Disallow query params to be used for image optimization. Let's see what this is. Maybe there's something here. Oh, they added this for additional security, so people can't use query params to spam you with more image optimizations. Good call. Reduce image size on mobile. Cancel images on mouse leave. What's this one? Or href equals slash. Return empty. Source components, UI, link TSX. Oh, do they have a custom link component? Let's take a look at that. Maybe that's where the magic's hiding. Ooh, this looks a little more magical. Let's see what's going on here. We have link, which is type of next link, but it's a slight extension of it. So what are they doing here? We have a use state with prefetched images. We have this preloading set preloading. Link ref is use ref. Routers use router. And then a prefetch timeout. If we have prefetch false, we don't do anything. Otherwise, we start. Link elements, link ref.current. If there's no link element, we bail. Now there is. We run the intersection observer. If this element is intersecting, then we set the prefetch timeout, and we do this prefetch, which appears to be mad about some ESLint shit. Exhaustive depths. Cool. I don't care. Go away. So we prefetch, you calling router.prefetch to tell the router, hey, fetch this thing ahead of time. We want the doc prefetch to happen first. This await sleep 0. This is a trick that I'll be doing a much deeper video on in the near future. Keep an eye out for my PPR video and how Next actually works. It's super fun. So we call the prefetch images function, and when they're done, we set images to be those prefetched images. And we unobserve. Pretty simple. And now we just use next link, pass in all the things we just defined, and specifically on mouse enter, we run the image preloading, and on mouse leave, we stop the image preloading. And on mouse down, we update the URL so that it updates immediately, by the way, because usually when you click on something, the action doesn't happen until you let go. Here, it happens right when you click, so you don't have to wait. But that's about it. And again, to be clear, none of these are things that you can't do yourself. And more importantly, none of these are things you actually need. This is just for the images to load as quickly as possible. You can just turn on prefetch true and get most of these benefits. But they're not actually prefetching the data, which is even crazier. As you see here, prefetch false. They're not prefetching the next page. They're only prefetching the images for the next page, which is really interesting because the images are the part that is slow. And you'll see that when you browse around the McMaster site, especially if I turn down the throttle or turn up the throttling, I go to slow 4G. Let's go somewhere we haven't been. Even now, see how slow those images load in? I'm hovering over flow and level control right now. I'll go here so you can see what happens when I do. I'm clicking it. All those images take forever to load in. Even if the route is ready to go, this is taking a while. And now it loaded, but the images are very slowly coming in. And again, to compare, I'll put it on the same slow 4G. I'm hovering. I click. It did just load a bunch of images, but not for this page, for the next places I go. So now when I hover this and click it, the images are already rendered. When I go to this one instead, the images are already there. So even though we have the same limitations here, the page loads immediately because that's not the slow part. Generating or fetching some static HTML from the server isn't a big deal. But the HTML isn't the part that's slow here. It's the images. Apparently, they do prefetch the URL on mouse enter. Oh, yeah. So props href, cool. So they disabled the traditional prefetching because they wrote their own. But if you just turn that on, it would do 80+% of this itself, just not the image part. But since they wrote their own prefetching, they also routed up prefetch the next URL. So when you hover, it will fetch the next HTML, as well as fetching all of the images that route needs. Super handy, super clever. This file is the only magic I've found so far, and I've been hunting. It doesn't seem like there's a whole lot of magic in this project. Is there anything here that I might be missing? I'll keep looking. We got buttons, but they're just buttons. Nothing here is magical. We got nothing in card. Seems particularly interesting. These are all just shadcn components. The magic's all in the link component, and this is a file you can go copy paste if you want to have all these fun behaviors in your app, but you also don't have to. The fact that getting something this fast is a single 150 line of code JS file that just changes link behavior slightly, it's really cool. So I was just talking about how that link file has a little bit of magic that you don't necessarily need, but could also copy paste and re-implement it yourself. Turns out you might not even have to, because Malta, the CTO of Vercel, is actually going to upstream some of the things that they did to make it even faster. As Malta says here, what's cool about the app is that it's mostly just plain old idiomatic Next. For example, just using route-based code splitting, Next font for automatic fonts, Next image for image optimizations, server components to prevent the JS size from increasing, all the things you normally expect. Partial pre-rendering for largely static delivery with server-side invoked dynamic parts. Yep, all cool stuff. But as Malta says, they do add some special optimizations beyond what the framework does by default. Additionally, there are some optimizations that end up not shipping because there isn't an idiomatic way to implement them in Next. Both cases are great learning experiences that can inform the future versions of Next.js. Here are some examples. Inlining CSS is an attractive technique because it allows rendering the first contentful paint with a single HTTP round trip. NextFaster doesn't do this, but the original McMaster does. It's not a good idea for many sites, but if the CSS itself is small, it's fine. What changes the equation is that with Tailwind, the CSS size never grows. And so inlining is actually probably right. Cool. Be dope to have that added in. They also call out the next link stuff that I was just mentioning. They have next link navigate on mouse down. I know this is a long time feature request for Next, and NextMaster ships it. It would likely be controversial as a default, but it would be a good opt-in. Fun fact, I have a whole video about John Carmack's take about mouse down versus mouse up for behaviors, and I have come around. I think mouse down is almost always better. It's also not possible to cancel a router prefetch invoke prefetch. This would be nice if they could cancel it. They have crazy ways they're doing it now. Be nice if that was built in. They also mention in the image prefetching. It would be nice to make this a first-class feature. Definitely has to be separate from the document prefetching, as you'd only want to prefetch images with higher user intent. Also a good call out. You wouldn't want to just immediately prefetch as soon as the page is being prefetched. You'd want to prefetch when the user's hovering or some other action has indicated that you really want to fetch all of the data. Because if you opened a page and it links to 50 pages, all with 20 images, you're loading 1,000 images just by opening that up. So that can't be a default, but you can do this right. Not the accessibility thing. This is not true at all. In fact, mouse down is better for accessibility. I go in depth on this in the video. There's a very real accessibility problem with mouse down, mouse up, which is there are many disabilities that make it harder to target a button that you're trying to click. No matter how able-bodied you are, when you let go of the click on the mouse, you will move some amount. For some people, that amount is more or less. So if the action occurs when you let go of the button instead of when you click the button, the likelihood of a misclick actually goes up. This is a much bigger deal in VR because the trigger is a way to click when you're pointing with a controller. When you let go, your balance changes slightly and you move up and down, which is why in every VR experience, everything is on button down, on press, instead of on release. It is more accessible, and every accessibility tool triggers a mouse down click. It's just not the case. I am not like a leading expert in accessibility, but I did run a lot of the stuff that we did for it at Twitch. I spent a lot of time talking to people using every single type of screen reader on the fucking planet. I have done a lot of work to make accessible experiences. Mouse down is not the reason your experiences aren't accessible. It actually helps more than it hurts. So yeah, I almost fell for that trap. I did a little more research. It's not the case in the slightest. Anyways, back to what Malta had to say. Right now, next image defaults to lazy by default. It's a good default, but it should be considered to make the first n images, like the first 5 to 10, eager by default, as they are more likely to be above the fold. I showed how that was implemented with the stupid little counter. That being built in would be really nice. They're working on getting all of these snuck in to be actually part of Next.js. So if you do want these optimizations, by the time you watch this video, they might already be in Next, which is really cool. That said, they were almost all really easy to implement in your code base. With a single 150 line of code file, you could get half or more of the things they're discussing here, which is nuts. It's so extensible and so good. It's surprisingly easy to write these types of super performant things within the Next model, and the result is 1/5 the JavaScript that you would have had to load to do it the way that McMaster did. I think that's pretty cool. I knew it was going to be fast when I went in. I didn't realize how much faster it would be than the project that it was built to showcase. I am blown away with the work that was done on NextFaster, and I even learned some things about how to optimize performance in my full stack web applications. I hope you did too. Let me know what you think, and until next time, peace, nerds. We don't need React Query. We have React Query at home. React Query at home. Giant use effect call that prefetches routes. Love it. Oh, man. This is wonderful.